Hello, I'm Bill Wagner.
And I'm James Sturdivant.
Let's now review some of the things in the code dealing with that abstract base class concept and how you can use it to communicate things about your design to other developers that might be looking at your code or trying to use it. So we'll look at different examples inside the base class library. Once again, we're going to look at some parts of the web stack because the web stack has been open source for quite some time, and we can really look at the implementation. We've talked about some of these when we were going through the presentation parts. We've got the MVC controller. Talked about that one already. Now, action result and view result base, James. What do those do in an MVC application? What are they part of?
Yeah, so action result is a part of the controller that it's actually returning the view part. And so as long as you inherit the action result, you're going to be able to write out the result from the web request that comes in. Okay.
And view result base sounds like it's one of the view things, part of the view part of MVC.
Yeah, exactly.
Yeah. Okay.
Yeah. So
look at that. And then we'll introduce the lab, and then we'll talk about our solution after that. So let's begin with that idea of the MVC controller. So James has got that project loaded up again. Yep. So we'll look at the MVC controller inside the ASP.NET web stack.
And cool. So what I'm going to do here is actually just show you another technique that you can use to open up various components in your Visual Studio. So if you take a look at my Visual Studio here, if I press Control, comma, I'm going to get a little text box up in the top right-hand corner, just up here. And so I can type in controller, and all it's going to do is find all the definitions of that controller and anything that implements that.
Okay, so that's like what I was doing, but instead of when I search in the Solution Explorer, it finds all the references as well. This is just going to find definitions.
You've got it.
Cool.
So if I hit Enter, it's going to bring me right to, maybe. You got to make sure you go to the actual C#. See the C#? The different little symbols there have different meanings. So
okay, so there's controller.cs. So we're back in that class.
Now that I've got the controller up here, we kind of take a look at this before. We took a little bit look at all the implementations and the implementation details we saw, but we kind of quickly brushed over the fact that this was an abstract class.
Right. So I'm kind of curious. So controller derives from controller base. Is controller base abstract as well?
Well, let's go take a look. We can do that by pressing F12 on the controller base.
Okay.
That's going to bring it up. And yes, it happens to be an abstract class.
All right. Now, is there anything in there that's any methods that are abstract? Or is this one just all?
Well, let's take a quick look. I don't know if there is.
I think so.
If there was, we would probably have to... Oh,
there we go.
There we go.
There's that execute core. So something that derives from this has to override execute core. Okay. And now notice the virtual keyword isn't there. Abstract includes this must be virtual, right? So we don't have to. So we don't have to write both. Okay.
And so did we talk about what virtual actually means here?
You know, I don't think we did when we went through inheritance. We talked about virtual methods.
Yeah. So abstract means that there's no implementation details, but when we have a virtual method, we actually provide a base implementation, but any classes that inherit from it can actually override that base implementation that we have.
So I could, in any derived class, I could override that same method, have the same signature, and the framework would call my overridden method instead of the original one.
Right.
So that's kind of how I can get that polymorphic, that different kind of behavior. Now with that abstract one, I notice there's no curly braces, there's no, it looks like an interface definition.
Yeah.
It just ends with a semicolon.
Yeah, you've got it.
So we get,
and that's because it is very similar to the interface in the way that we think about how they're actually going to be implemented.
And unlike an interface, though, I can have these abstract methods with accessibility keywords. This one's protected. So I've got this abstract method that is only accessible to derived classes, but it's not public.
Yeah, that's a great differentiation from an interface and
okay, so that would be one of the reasons to look at an abstract-based class when we dive deeper into these, is if I want to have that thing where I need some accessibility on it, I can get that with an abstract-based class, and not so much with an interface. Okay.
What I find interesting is if we go back over to the controller method, we haven't found that, does it actually implement it up here?
I think it will.
Execute core, yes.
Okay, so it's going to override it. So it does this. So now, cool.
And we kind of already looked at this implementation previously, where it's going to load some of that temporary data.
Right.
It's going to go and find the actual action. And if it can't actually find the action it's looking for, it will go ahead and return the 404 for us.
Right. Okay. The 404 for us? 404. All right. So, okay, so that's interesting. So now in this particular class, this controller class, it's provided an implementation of the abstract method in the base class. Does it declare any abstract methods that we need to override when we create our own controllers?
In this controller, it actually doesn't do that.
Okay, so the only reason this class can't be instantiated is because they declared the entire class abstract. There's nothing we have to override in our own methods. You know, and we kind of talked about that in the slides, right?
Yep. And the reason for that is because if we were to make a web request, the base framework itself wouldn't actually know what actual URLs and what requests that you want to be implementing. And so here it's saying that you cannot be a controller without providing some of that additional information.
Okay. So what we've seen so far is that base controller, and maybe there's are there other things that derive from base controller? I'm just
That's a great
curious
question.
to see.
Go
Because
back up
what
to
we've
the
learned so
top
far is this ultimate base class for controllers, you know, it's got an abstract method that must be overridden, right? But if not, well, okay, then we can't derive from it. But then the one that we derive from doesn't have any abstract methods. It's just got this contract that says, yeah, you can't do that. So that's an interesting way to sort of chain these two together.
Yeah, so if we go back and look at that controller base, there is nothing else that it's inheriting from, but it does have an interface on it.
Right.
And that if we go take a look at that interface, all it's doing is providing us this execute function.
Now, are there other derived classes from the base controller? You know, if we go back to the controller itself, you know, if you right-click and if we find all references,
controller.
Yeah,
Not
that one, the controller base.
Yeah, okay.
Yeah.
I think if we go like that, all references.
And see, you know, are there other? So it looks like there are other things that are derived from it as well. So other kinds of controllers that we might want to use for other purposes.
Yeah, it looks like most of this is for testing.
For testing for other things there. Okay, so.
But if you wanted to provide your own custom controller that you're going to be adding some extra information or implementation details that are slightly different than the one provided, you could go to that.
So the design is set up for that, even if it's not in this same project. Okay. So now the next one that we wanted to talk about, we wanted to go into that action result class. That was the second one that we were going to look at. So and you say that's part of the views and the results that come out of a controller method. So so what have we got there?
So yeah, I'm pulling that up right now, using that same technique of using control comma. And if we look at this, we've got an abstract class that executes the result based on the controller context. So given all the information about the controller, we want to execute that result and hand it back out to the system and who's calling. Okay,
so this one I find really interesting for a couple different reasons. Okay, the class is abstract. It's got one abstract public method. This could easily have been an interface, right? A public interface action result with that execute result method.
Right.
Right. So I'm really wondering sometimes, what do you think that design, you know, the way they did that, why did they make that an abstract base class? I mean, we don't know. We're not talking to the developers, but what does that communicate to you when you read that code?
Yeah, I think right here, one of the reasons we would do that is because we wanted to be able to specify the
that public accessibility.
Public accessor. So potentially we could be able to. Oh, we kind of talked about this in the past one, but we could also do make it this protected, and so we could potentially go there. But in this case, I guess because it's public, what we're really trying to do is, if you do inherit from action result base, then what we're trying to do is prove that we don't want you to be able to inherit from something else. So we're taking that one inheritance that
because classes can only have a single base class.
Yeah.
By defining it to say, we want this to be your base class, what they're sort of saying is you can't pick a different base class and derive from something else and implement this interface.
Right.
Right. So they're trying to say this has to be derived from this thing.
If you want to be doing this action result.
Got it. Okay. So then, where is action result used?
That's a great question. I think it's
in other words, one of those we wanted to talk with was the view result base was one of those that we wanted to look at.
Yep. So now we've got that pulled up here.
Okay.
We can go ahead and see.
So it's also abstract.
It is. Yep.
Okay.
And that's because later on you might want to, this is only providing some extra information. And so we can, in a few minutes here, we can take a look at what actually uses view-based result, or view result base.
Okay.
But what I think is interesting here is it's providing some extra information. But if we go all the way down to the bottom here, the really interesting part is that it has an abstract function on it.
Okay.
And that's being exposed.
Okay, and again, that's that protected thing. So our derived classes have to put this together, and it's not public. It's only going to be used by view result-like things. Right. Something that is a view result base.
Yep.
Okay.
So let's go and see if we can find out what uses view result base here by going to find all references.
Oh, that's a smaller list at least. I feel a little better there.
Yeah. Exactly.
So it looks like that view result one would be a good one.
Yeah, and so this is the view result, and this is the thing that does all the handling for displaying information in your MVC
so that's going to load my CS, HTML, my Razor view, and then display that stuff. Yep. Okay.
And you can see here that it actually overrides that protected abstract method that we were looking at before and provides a definition for us.
Okay.
And here it actually goes, it finds a particular view, and if it doesn't find the review, then it just passes on the result.
Got it. Okay.
And then down here, what it's doing is it's going to spit out. So if it doesn't find it, it's going to spit out all the places that it looked. And so that's going to help us to be able to debug.
So if I forgot one of my Razor views somewhere, it's like, this is what I couldn't find.
Yep.
Go look for this. Okay.
Yeah. And that's I find that always becomes very helpful for us.
Yeah, we've all seen that. Okay. Too many times in production. Yeah. No.
Yeah.
Okay, so that in that view result thing, so what I find interesting, if we go back to the code for just a second, that's a small class. That doesn't look like there's a lot in that particular class, right? I mean, if we go to the bottom, I mean, we kind of went through, that's 40 lines of code here for my view result base.
Yep.
Because we're leveraging all those things in view result base and in the one with action result underneath it. So that's interesting. That's again why we used class inheritance is to be able to reuse that implementation.
Yep.
Right. Okay, cool. Good things to see. So now let's look at what you can do inside your small hierarchy. So we've got one small exercise here. And again, the interesting part from this is not so much how much code you write. When we looked at this code review, this was noticeably smaller than the things that we chose for, say, encapsulation, where we're trying to show how we hide a large algorithm. But it's more how do we want to express what we mean for you to do with these different types. And as we look at this lab, one of the things that I really want in terms of looking through this concept, there's a great quote by Rico Mariani, who was one of the architects for the .NET BCL in its initial releases, where he said that success shouldn't be this summit in a far-off distance that's really hard to get to. We want success to be as easy as falling into a pit. That's where that pit of success came from.
Okay. Yeah.
It should be super easy, right? You can't do the wrong thing. So when we're trying to build classes that we want other developers to use, the big thing we're trying to do is we want to prevent you from misusing the code that I gave you, right, that I developed for you. Because if you can't misuse it, you won't write bugs, right? That simple. So in this section, what we want to do, we're going to revisit our hierarchy and find out, any of the classes that we made so far, should they be abstract? Are there types that we just don't think will ever instantiate in this particular application? And we really want to think about, is that by design? Did we intend these to be abstract-based classes? Or is it just because the features we've put together, we just haven't made one yet? And should any of those abstract types have abstract members? In the code review that we looked at, we saw some that had both. There was abstract classes that had abstract methods you had to override, and we saw abstract methods or abstract classes that didn't have anything we needed to override at all. Both are perfectly valid, and they communicate something different to the people trying to use those classes. This one doesn't take a lot of code, but I want you to spend a little bit of time thinking about it. And thinking about, if I don't make something abstract, what would happen in the future? If I do make it abstract, how does that change how it could be used in the future? And we'll come back, and it's a short summary of what we built. And we'll talk about why we made the choices we did. And then we'll move on to generics. See you soon.